Hello everyone, my name is Shekhar Shrivastava and I'm a PhD research scholar from Department of Industrial and Production Engineering at Dr. B.R. Ambedkar, National Institute of Technology, Jalandhar, India. So today I'm going to demonstrate you an in-house developed wire and arc additive manufacturing setup which I have developed during my PhD research work, and I have utilized this machine for the deposition of my experimental sample as well. So this complete setup is in two parts. The first part is this arc welding machine. This is basically an EWM Phoenix metal inert gas welding machine. So this is basically a state-of-art arc welding machine which can deposit mild steel wires, stainless steel wires, aluminum alloys wire, and Inconel alloys, titanium alloys, and many more. So this is basically a setup which can be able to control very precisely, like voltage, current, wire feed rate, voltage correction factors, pulse and non-pulse mode during and before the deposition very well. So for my deposition, I have actually used mild steel specimen. So for that, I have used ER70S copper coated mild steel filler wire. Along with that, I have used two different type of gases for shielding. The first one is this pure argon, 99.9% pure argon gas, and the second one is CO2 gas for the shielding. So with the help of this wire feeder unit, we can control voltage during the deposition or before the deposition. Also we can control the wire feed rate as well. So basically I have used this machine for the deposition and I have basically connected its welding torch with the help of my developed machine so that I can deposit my desired specimen through it. So this is the second part of our developed machine, such that wire and arc additive manufacturing process. As in the previously we have seen that the power source in the form of MIG welding machine. So in here you can see that the welding torch comes from the MIG welding machines. MIG welding machine is coupled here actually. This is the place where we couple our torch according to the deposition and our required geometry of deposition. Now after coupling the torch with the help of required coupling, here you can see that we actually set up parameters, weld parameters like voltage, current, wire feed rate, and type of gas, and the gas flow rate in our welding machines. After confirming all those parameters and earthing condition in our machine, we intend to deposit our geometry. So for geometry actually we use any 3D solid modeling software like Creo we have. In Creo actually we develop our intended geometry. So in Creo itself we can change the geometry of deposition into dedicated G and M codes, which is responsible for the interpolation of this torch. So now for the interpolation of this torch in XYZ direction, I have used a dedicated stepper motors for all the three axes with the help of Arduino system. However, to provide motions and to read the dedicated G and M codes from Creo softwares, I have used UGS platform software. So in this box you can see that we have confined the placement of all the motors, Arduino setup, SMPS for power supply, and all other gadgets which is required for the control of motion in different direction like X and Y and Z direction. So with the help of lead screw and timing belts, we have provided motions to different lead screw which is running in X and Y and Z direction respectively, and after that providing the geometry G and M codes, we intend to deposit the component by turning all the machines simultaneously.